So, as always, we are going to give people a little bit of time to show up. So just maybe another minute or so, and then we'll get things started here. All right, let's go ahead and get things started. So, if you guys came over from the summer class, we were on, we were in the middle of the 2019 exam. We only had about 2 more questions in that exam that I really wanted to cover. Again, the point being is that when it comes to the AMC, some of the questions on the exam are going to be, the later questions on the exam are much, much more difficult than the rest of the exam, right? So the point of this class is not to get you a perfect score. The point of this class is to get you a good score, right? So we're going to look at pretty much all the questions up until the last couple problems, right? So we're going to look up into around problem 20, 21, 22, around when I think, question gets pretty difficult. So we're going to take a look at that, and then that's going to be as far as we go. And then we're going to move on into the next set of questions. So the last couple problems, last 2, 3, 4 questions, we're not going to look at them. Okay, so we have 2 last problems that I want to look at. Those are going to be problems 21 and 22. Let's take a look. So problems 21 and 22. Any volunteers actually for problem number 21, first off? Going once, going twice. All right, let's hear from Yao Xiaowen. Let's hear from you.
What is the area of the triangle formed by lines y equals 5, y equals 1 plus x, and y equals 1 minus x?
So are you familiar with graphing lines like this? Do you know how this works?
Yeah, I can graph those lines.
Okay, so can you kind of explain to me what this looks like in the XY coordinate plane? So first off, for anyone who's not familiar with this, this is something that you learn in the Algebra 1 book. So I want to say this is Algebra 1 around chapter 8 or so. This is when you're going to see how to graph lines using equations like this. The general idea is you have a coordinate plane, which is an x-axis and a y-axis. The x-axis goes horizontally, y-axis goes vertically. And the idea is you just label points, right? So y equals 5 is all of the points on this graph that have a y coordinate of 5, or in other words, just a straight line horizontally with the y-axis of 5. Does that look good to you?
Yeah.
Yeah, so this is y equals 5. Okay, what about my second line? My second line is y equals 1 plus x. What does this look like?
Y equals 1 plus x. Well, I usually just plug in numbers for x and graph them.
Yeah. So what numbers could you plug in here that would be pretty easy to use?
Assume x is -1, then y would be 0.
Yep.
And if x equals 0, then y equals 1.
Yep.
And if x equals -2, then y would equal -1.
Yeah, and then once you have a couple points, you can kind of get an idea of what this looks like, right?
Yeah.
Something along the lines of this. And I agree with you here, right? So this is my y equals 1 plus x line. Now, something else that you can do here is you can actually if you're a little bit more familiar with this, you can actually represent this using what's called slope and an intercept. But that's something for if you have taken the Algebra 1 class that I would expect you to know. Otherwise, I would not expect you to know this. But the important thing here is, do you know where this intersects the y equals 5 line? Do you know where that point is? The point that would be in the middle between both of these right here.
Wait, what do you mean?
Like, for example, what point is on both the yellow line and the blue line right here?
Oh, wait, you can use those systems like of equations and stuff.
Yeah.
So should I do a system of equations for all three of them, or just two?
Well, the idea is you want to find that point of intersection, right? So the point that both the yellow line and the blue line share, right? So what that means is I need to both be y equals 5
and y
equals 1 plus x, right?
Mhm.
Exactly. Well, what you know from the first line is y is equal to 5.
So you can use the substitution.
Yeah, 5 equals 1 plus x. What is the value of x here?
X equals 4.
So this point here has to be 4, 5. Would you agree?
Yeah.
Okay. And as for my other line, we can do something very similar. This last third line, 1 minus x, we can do something along the same lines. You should find that it looks something along the lines of this. What you may notice is one of the points that you may have tried was 0, 1. So you would actually already know that that intersection is that point. But now the question is, well, what is this point of intersection here? Well, very similarly, you could say y equals 5 and y equals 1 minus x. 5 equals 1 minus x. What is x equal to here?
X equals 6. I mean,
negative 4.
Negative 4.
Yeah, negative 4, 5. You can also double check that, right? Negative 4 is on the left side of 0, right? Well, that makes sense here, right? Because it's on the left side of 0. Okay, so now the question is, we want to find the area of this triangle. Does that make sense here?
Yeah.
So how do I find the area of this triangle?
You find the height and the base and divide it by 2.
Yeah, if I can find the base length here multiplied by this height, that's going to work, right? Why do I use this base and this height? Is there any reason why I do this specifically? The reason why is because these distances are easy to calculate. That's pretty much it. It doesn't really matter which base I use as long as I am able to get a height that makes a 90-degree angle with it. For example, if I used this base, I would have to find a 90-degree angle with that. It turns out that that's actually just this, but that's a story for another day. It's a lot easier to use this base here and this height here. Would you agree?
Yeah.
So what is the length of the base here?
You can use like a distance formula or just.
This is actually a lot easier than the distance formula because it's a straight horizontal distance between the two. So I can just count the horizontal distance.
And then it would be. No.
From negative 4 to positive 4.
It'd be 8.
Yeah, and what about the vertical distance from here to here? That's from 1 to 5, right? So how long is that distance here?
It'd be 4.
So my area is then how much?
16.
Does that make sense?
Yeah.
So my answer here is 16. That's it. So this actually introduces to us a couple of ideas. The first one is how to graph these lines. That idea is something that you don't really see until Algebra 1. That's an Algebra 1 Chapter 8 technique. But being able to draw this out on a graphic, and then from there using base times height here, that's an idea from geometry. This is one that you typically don't really see until then. I would say that's also that's like a geometry chapter 16 technique, so pretty late in that book, but I think the general idea here is a lot easier than but then actually going ahead and doing that. Actually, no, this is geometry chapter 17. Oops. But these techniques here, right? When we boil it down, it's just base times height. As long as you're able to draw out where those points are, as long as you're able to think about it the correct way, base times height here is not very difficult. And especially because it's just horizontal and just vertical distances. We don't even need to use the distance formula or anything like that. Any questions over how this problem worked out? I promise you between 21 and 22, this one is the more difficult question. So with that, let's take a look at problem number 22. Problem 22. Any volunteers here? Once, going twice. About Angel. I don't think I've seen, I don't think I've had you before answer a question. Can you start by reading the problem?
A store increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased?
So when we say that the store increased the original price by a certain percent, what did we do to that number, essentially? Do you know what I'm asking here, basically? So Angel, let's say, for example, right? Let's say, for example, that percent was 10%, right? If I increase by 10%, what is my new price going to be after that 10% increase? Any ideas? No? Okay, sure. Lindsay, what is that going to look like?
That's gonna, well, let's pretend X was the original price. So it would be X times, in parentheses, 1 minus 10%.
Well, that's if we decrease by 10%.
I mean, 1 plus 10%.
Right. So if we increase by 10%, that's going to be 1 plus 10%, right? And then 10% is just 0.1, right? So that's the idea here. And then if we then decreased by 10%, what would that look like then, Lindsay?
It would be X, parentheses, 1 minus 0.1.
Right. But since it's the post increase price,
yeah.
it would be this amount times 1 minus 0.1. Does that make sense?
Yeah.
Yeah. And that's what we're looking at here, right? So that's the general idea, right? So we're increasing by some percent, then we're decreasing by some percent. And then when I divide by, when I say that this amount was 84% of the original price, right? That means that this is equal to 0.84 times the original price, which is X. Does that make sense? Except we don't know what the amount, we don't know what the percent we increased by was. That's another amount that we don't know. So this is some percent over 100. Some percent over 100 is equal to 0.84 times X. That's the general idea here. Now, what we can do is we can actually get rid of the X. We can divide both sides by X. So this gives us 1 plus a percent times 1 minus a percent is equal to 0.84. Lindsay, does this look good to you so far?
Yep.
Okay, what can we do now? From here, what can we do?
Maybe we could get rid of the parentheses.
How? What is that process called?
Distributive property.
Yeah, we can distribute things, right? So the distributive property says A times B plus C is equal to AB plus AC. I know this looks a little bit more complex than that, but I promise you if we just do it twice, we're going to get where we want to go. So if we do this times 1 minus this times this, let's call this percent over 100. Let's call this a different number, right? Let's call this maybe y. So 1 plus y times 1 minus y, right? So we get 1 plus y times 1 minus 1 plus y times y. Does that look good to you?
Yeah.
And then we can distribute another time here and another time here. So this will give us 1 plus y minus y squared. Or in other words, 1 minus y squared is equal to 0.84. Does that look good to you?
Yep.
And now what can we do?
Well, we're gonna solve the equation.
Yeah.
So like move and isolate the y squared.
Yeah, so if we move y squared over to the right side, that becomes 1 minus 0.84 is equal to y squared, right? Moving 0.84 to the left side as well. So that gives us y squared is equal to 0.16. What does that mean? Does that mean our answer is A, 16?
No, because it's y squared. You have to like square root it.
Right. So what is the square root of 0.86? 0.16?
Y is 0.4.
You can think of this as 16 over 100. Square root of that is equal to 4 over 10, right? Square root each the 16 and the 100 to get 4 over 10. Our answer here is E, 40%. So that's going to be the correct answer here. 40% is the way to go. This technique requires information from both. I want to say chapter 7 of the Algebra 1 book, as well as, oops, this is chapter 6. So this is chapter 6 of Algebra 1, as well as chapter 11. So the more difficult questions in the AMC will take on multiple pieces of chapters rather than just information from a single chapter. So this is where that information comes from. But again, right, if you understand, oh, you know, if I increase a price by a certain percent, right, I just multiply by 1 plus that percent. If I decrease by a certain percent, I just multiply by 1 minus that percent. And then from here, what we did was we said, okay, well, that's just equal to 84%. And then what we did was we solved 1 plus y times 1 minus y, right? If we actually knew this already, this is in the format of a plus b times a minus b, which is actually a squared minus b squared, which is exactly what we did here, 1 minus y squared, right? So if we actually already recognized this, we could have skipped that step and directly expanded this. But that's something, you know, if you're familiar with that, you could use that there. But that's going to be it here for problem number 22. Any questions over any of the steps that we did here? So again, this is something that you typically find in Algebra 1. So if you haven't learned about that, then that's probably why this is a difficult question. But with that, that's going to be all the questions that I want to look at here. We're not going to continue on into the last couple problems. The last couple problems are much, much more difficult than this. So with that, that moves us on into the AMC8 from 2018. So let's take a look at those problems. Starting off with problems 1 through 3. Right. Problem number 1. Any volunteers for problem number 1? Once, twice. All right. Brandon, let's have you help me out here. Problem number 1. Brandon?
What question am I doing?
Problem number 1.
Amusement park has a collection of still models. There's a 120 radius of buildings and other sites from around the country. The height of the United States Capitol is 289 feet. What is the height in feet of its replica to the nearest whole number?
So the ratio is 1 to 20. If the real one is 289, what can we expect the replica to do? So let me ask you here, Brandon. If the real one is 20 feet, how big is the replica going to be? Any ideas?
Maybe about 15 short.
54? Is that what you said?
No, 15 short.
15 short? What do you mean by that? So are you saying 15 is the answer?
No.
So what the ratio of 1 to 20 means is what that means is I can set up a ratio between real between scale to real for anything, right? So scale divided by real is always going to be equal to 1 over 20. Does that make sense?
Okay.
So that is going to be equal to my replica divided by 289 feet. So the replica height divided by 289 is equal to 1 over 20. Does that make sense? That's what this ratio of 1 to 20 means. So then what we can do is we can say, okay, well, the replica, well, what I can do from here is I can set up a cross product. I can set up cross multiplication. 20 times the replica is equal to 289. So then in order to solve for the amount the replica is, I just need to divide by 20. Divided by 20 gives me the replica is equal to 289 over 20. Does that make sense? So what I'm asking now is what is 289 divided by 20 rounded?
Can you repeat that, please? I couldn't hear you.
What is 289 divided by 20 rounded to the nearest whole number?
Okay.
Well, this is equal to 14 and 9 over 20.
The answer is the answer is 14, 9 as the remainder.
Right. So is that closer to 14 or is it closer to 15? Since we're rounding, right? We're rounding to the nearest whole number.
14.
It's closer to 14 because 10 over 20 would be exactly 1/2. That's when it would start rounding up. But 9 over 20 means you round down. So that's the answer here. Our answer is 14 because we round down. So this technique here, the method that we're doing here is this is one from the Algebra 1 book, chapter 6. You will also see this in the pre-algebra book, I want to say chapter 7. So that's where we see this. This is a ratio, and that's where we answer that. So this is more along the lines of what you might see in a pre-algebra book. So pre-algebra chapter 7, that's where you see this type of problem. All right. Any questions over problem number 1? If not, then let's look at problem number 2. Any volunteers? Evelyn, let's go with you.
So you basically I saw that 1 plus 1 over 1 was 2, and then you multiply that by 1 and 1/2, and that was 3. And if you like keep going with the next one, that becomes 4. And like that was like the pattern, so I got 7.
7 here. Can you do a little bit more to explain, like, so what are each of the terms here?
So the first, like if you like add up the numbers in the parentheses, you get 2 times 3 over 2 times 4 over 3 times
2 times 3 over 2 times 4 over 3, you said?
yeah, then times 5 over 4, then 6 over 5, then 7 over 6.
Right. So this one is just this, right? This one is that, this one is that. We're just, we're just adding together the numbers, right? And then what you noticed is
The new, like the ones next to each other, they like canceled out. I don't like the 2 in the denominator of 3 over 2 like canceled out.
the right, the numerator and denominator cancel out.
And the other ones also canceled out, like the 3 and the 4
Mhm.
and the 5s and the 6s. And then you're left with 7 over 1.
Yeah, and that's exactly why D is your answer, right? So everything here cancels except your 7, right? So if you actually went ahead and multiplied all of these numerators together and all of the denominators together, you'd be here for a while. You'd also be here for a while doing that division. But the idea here is it's much easier to cancel, right, as you go along, right? And then if you canceled out, everything cancels except for the 7. So you're left with just 7 as your answer. That's exactly it. Any questions over this one? So it's really important for this question to be familiar with how to cancel, how to cancel those numbers. That's what we see here going on. So for example, if you multiply something like, 3 over 4 times 8 over 9, right? You want to be familiar with being able to say, oh, I can cancel out a 4 here. This is just 2. I can cancel 3 here. This is 3. My answer is 2/3, right? That's going to save you a lot of time when it comes to competitions. It's also going to save you a lot of time when it comes to problems in school as well. This is something that you really want to be familiar with. Okay, problem number 3. Last one here before we move on to the next group. Any volunteers here? Once, twice? Okay, Lindsay, sure.
Well, students Arn, Bob, Sid, Dan, Eve, and Fawn are arranged in this order in a circle. In that order in a circle. They start counting. Arn first, then Bob, and so forth. When the number contains a 7 as a digit, such as 47, or is a multiple of 7, that person leaves the circle and the counting continues. Who is the last one present in the circle? Well, so I just drew out A, B, C, D, E, F for like Arn, Bob, Sid, Dan, Eve, and Fawn. And then
Not
I
exactly
just
a circle, but good enough.
yeah.
Sorry, I'm just commenting on my own thing. Right.
And so you start with A, and then you go, and since there's 6 people, Arn is out on the 7th one.
7 out, right?
Yeah, and then since there is 7, and then there's no more numbers in the ones digit that has another one that includes 7, so then you just continue 8, 9, 10, 11, 12, 13, 14. 14 is a multiple of 7, so C is out, and then 15, 16, 17 includes a 7, so F is out, and then it's just B, D, and E. So 18, 19, 20, 21, B is out, and then 21, 22, 23, 24, 25, 26, 27. So E is out. So the answer is D, Dan.
Yeah, that's pretty much exactly the easiest way to do this. I promise you the easiest way to do this is just draw a circle with the letters A through F and just do this. Just write them out one by one, cross them off one by one, and you're left with Dan. That's really just the easiest way to do this question. Yeah, I mean, this is I guess this is pre-algebra chapter 15. I want to say chapter 15.2 or so, but that's kind of where you see this idea. But I promise you this is yeah, you just draw this out, right? Sometimes just drawing a picture, working it out the exact way the problem says is the easiest way to do it. And that's the situation here. If you try to do any math, I promise you it's just going to be even harder. So that's what we see here. Problem number 3. Problem number 2 here, this one I didn't exactly mention. This is really just, understanding how to cancel in a product. I guess this, if I had to put this somewhere, this would be pre-algebra chapter 15 as well. But the idea is recognizing patterns. And the pattern here is, all the numerators and denominators cancel out, right? So that's what the pattern is here. Any questions over any of the first 3 problems here? So for those of you who are here for the first time, I didn't go over this earlier, but if you guys have any questions, please make sure to ask. If you don't ask, I won't know if you have any questions. But if you do have questions, please make sure to either ask them, directly, or feel free to send them as a message in the chat, right? You don't have to ask out loud. You don't even have to ask everyone. If you don't want to, if you don't want others to see what your question is, please send it to just me. There's a box that says to everyone by default, but you can change that to just me. And then if you do that, then I can be the only one that sees your question. I will need to read it out loud so everyone knows what I'm answering, but I will not say who it came from. So it'll be an anonymous question there to everyone except me. But there's no way to make questions anonymous to me. But yeah, so that's what we're looking at here. Any questions over the first 3 problems? If not, then let's keep going. I have problems. 4 through 5 here. Let's take a look. Problem number 4. Any volunteers? Let's try to get someone new. Sorry. Let's hear from, sure, Matthew, let's hear from you.
I noticed that there are these there's a we can draw a square in the middle made of 9 9 units.
So you're saying draw a square in the middle, right?
Yeah.
Okay. All right, what else?
So that would be 9 units inside the square. So then I noticed that what's left are these triangles, and each of those triangles would be 1 unit because each of the half triangles is half a unit. So that'd be 4 units. So then 9 plus 4 equals 13.
Yep, that's exactly it, right? So each of these is a unit of 1. So 9 plus 1 plus 1 plus 1 plus 1 is 13. That's exactly it. C is our answer. Any questions over problem number 4? It's a pretty quick one. So the idea behind problem number 4, this one is one that you see in pre-algebra. I want to say pre-algebra chapter 11. But the idea here is instead of viewing it as, one entire shape, we break it up into easier to look at shapes, right? We break it up into 1 square and a bunch of triangles that help out. That's the general idea here. Okay. Problem number 5. This one's a little bit more interesting. Let's see what we can do here. Any volunteers before I volunteer to do it? Going once. Twice. All right. Richard, how about you?
So you split the problem into two halves first. So what is the value of 1 plus 3 plus 5 plus something, and always keep on going to 2019, then minus 2, minus 4, and then keep on minusing to 2018. So you just split it between plus 2019 and minus 2.
Okay, so you're saying look at this group here and then look at this group here. Is that right?
2019
Oh, never mind. I found a better problem. I mean, a better way. I found a better way. So every time you have a 1, you have a corresponding minus 2 on the other side. So basically, you can literally just cancel them to get minus 1, like negative 1. And you can keep on canceling for a number of times.
Okay, so what you're saying is 1, you have a minus 2, right? 3, you have a minus 4. 5, you have a minus 6. The idea is for any number in this first group, you have a negative number in the second group. That's 1 bigger than that, right? So I do agree with you, right? So you can go from here all the way down to 2017 minus 2018. So the idea is each one of these is a sum of, well, negative 1, right? Each one of these is a negative 1.
But you also have to add the 2019 at the end, because there's an extra one.
Exactly, because there's one extra 2019 here, so we need to add that in at the very end. So now the question is, well, how many numbers are there here? How many negative 1s are there? That's a really important question that we have to answer. So how many are there?
You can just count the number of numbers in the second half. So basically the number of even numbers from 2 to 2018, which would be 1009 numbers. So it will be 1009 negative 1s.
So how did you know that this is 1009 numbers?
Because since you have a sequence from 2 to 4 to 6 all the way to 2018, like you can divide by 2 so that the 2 would be 1, the 4 would be a 2, and then the 6 would be a 3, and all the way down so that 2018 divided by 2 would be a 1009, and then you will have a clear counting sequence of 1, 2, 3, 4, 5, 6, and all the way to 1009.
Yeah, that's exactly it. That's exactly the reason why there's 1009 numbers here. That's exactly why you're able to do that. It's also, I do agree with you, it's a lot easier to count the number of numbers in the even group rather than an odd one. That's something that helps out a lot. But yeah, that's exactly it. And then what you can do is you can just do 2019 minus 1009. That's equal to 1010, which is E. That's exactly what we're going to do here. That's definitely one way to do this question. It's one of the easier ways to do the problem. There is another way. So had you wanted to go down your path of separating it out as this group here and then this group here, the sum of the numbers 1 through 2019, that's equal to so 1 plus 3 plus 5 plus all the way up to 2n plus 1 squared actually turns out to be just 2n minus 1 squared, sorry. 2n minus 1 actually ends up equaling just n squared. That's the, sorry, yeah, 2n minus 1, that's equal to n squared. The reason for this turns out to be a little bit difficult to prove. This is just a formula that I've memorized at this point. So an example here is like 1 plus 3 plus 5, right? 5 is equal to 2 times 3 minus 1. Well, this is equal to 3 squared, right? So the idea here is what you could do something similar. You'll find that this is equal to 1010 squared. This one you'll find out is equal to 1 plus 2 plus 3 all the way up to plus 1009 times 2. This one you'll find is equal to 1009 times 1010. So the difference between these two is equal to 1010 itself. That's another way that you could have done this question, but I don't expect you to know either of these two formulas. Those two formulas are both formulas that you won't know unless you have studied this on like separately and went and learned all these formulas. But that's another way that you solve this question. This one is the easier method. This one is, again, I would put this under pre-algebra, chapter 15. It's a pattern question, and the pattern is everything adds together to equal -1, and then you just count how many negative ones you have. You could have also paired up the bigger number here with the smaller numbers here. That would have given you positive ones. It would have given you 1009 positive ones, and then plus another 1 at the start, which would have given you the same answer. That's another way we could have done it. Any questions between problems 4 or problem 5? Problems 4 and 5. Any questions here? All right. In that case, then we move on to the next 3 problems. Problem 6, 7, and 8. Problem number 6. Let's see. I think the only 3 I haven't called on are Alex, Stella, and Yuhang. So we're looking at the 3 of you here. All right, let's start from the top. Alex, problem number 6.
Should I read the problem?
Yeah, always.
On a trip to the beach, On traveled 50 miles on the highway and 10 miles on a coastal access road. He drove 3 times as fast on the highway as on the coastal road. If On spent 30 minutes driving on the coastal road, how many minutes did his entire trip take?
Okay, any thoughts here?
So since he spent 30 minutes driving on the coastal road, and he drove 10 miles, then we know that he drove at 20 miles an hour. And
how did you get that number?
Because it's he drove 10 miles for half an hour. So if you double that, he would drive 20 miles in an hour.
Yeah, I think that makes sense, right? So in 30 minutes, right, half an hour, he drives 10 miles. So double that amount of time, get 1 full hour. Well, that's going to be 20 full miles, right? So that's the idea here. I do agree with that here. Okay, so 20 miles per hour on the coastal road.
And then it says he drove 3 times as fast on the highway. So we just multiply 20 miles per hour by 3 to get 60 miles an hour.
Yep.
And it says he drove 50 miles on the highway. So we know he spent 15 minutes driving on the highway.
How do you know that?
Because he traveled 50 miles and if it's 60 miles per hour, then there's a mile a minute. So he drove 50 minutes.
Yeah, that's exactly it, right? So because 1 mile per minute is the same thing as 60 miles per hour, that means that 50 miles is the same thing as 50 minutes. So our total amount of time is 80 minutes. That's exactly it. Yep, nice work. So this idea here, all we're doing here is we're just making use of the definition of speed. Speed equals distance divided by time, right? And that idea is one that you should typically learn around chapter 7 in the pre-algebra book. So this is where that comes from. So it's chapter 7 in pre-algebra. You'll notice if this is your first time here, you'll notice that many of the first couple problems are all pre-algebra problems, and that's something that you'll see a lot of. Up until problem 10 or 15 or so, you'll see very many pre-algebra questions. All right, problem number 7. Stella, Yuhang, looking at you two. All right, Yuhang, how about you?
The 5-digit number 2018 U is divisible by 9. What is the remainder when this number is divided by 8?
So do you know how to test if a number is divisible by 9?
No.
So this is something that you learn in the pre-algebra book in chapter 3. So pre-algebra chapter 3. I want to say this is 3.3 or so, maybe 3.4. But that's around where you learn this. So the divisibility rule for 9 is if all the digits add up to a multiple of 9. So for example, if I add together every single digit here, I need to get that this is a multiple of 9 in order for the original full number to be a multiple of 9. So what does that mean? What that means is 2 plus 0 plus 1 plus 8 plus u equals some multiple of 9. So what is this number here? This number here is 11 plus u. What does that mean u has to be equal to? Yuhong?
7, something like
Yeah.
that.
Yeah, u has to be 7, right? Because 18 is multiple of 9, u has to be equal to 7. One other thing to keep in mind is u also has to be a number between 0 and 9. It cannot be any bigger, cannot be any smaller, right? Because it's a digit. So that means that u must be 7 in this case, right? So in this case, then the number that I'm working with is 20,187. So 20,187. Now the question is, what is the remainder when this number is divided by 8? Do you know how to do that?
Wait, what?
What is the remainder when this number is divided by 8? When 20,187 is divided by 8?
No.
How do I do that? So one way that you can do this is you can do this directly by just dividing. If you just directly go ahead and divide the whole thing by 8 and find what your remainder is, you could do it that way. The other way is if you know the shortcut. The shortcut is, it turns out, all multiples of 1,000 are multiples of 8. So whenever you are working with a number and you're trying to see if it is a multiple of 8, you only need to look at the last 3 digits. Or in other words, this is 1, 8, and 7. So now instead of asking you, okay, what is the remainder when 20,187 is divided by 8? The question now is, what is the remainder when 187 is divided by 8? Here you just actually have 5. So 18 divided by 8 is 2, 16, 27. That's going to be 24, remainder 3. So our answer here is B, remainder of 3. Any questions over how these two divisibility tests work? So this is just a divisibility test question. You do sometimes see these problems, and there are a bunch of rules for this. For the AMC, I would recommend understanding the rules from 2 up to 11. Skip 7. 7 is not, 7 is 7. There isn't a rule, so you can skip 7. But everything else, 2, 3, 4, 5, 6, 8, 9, 10, 11. There's rules for every single one of these. So this is one that you want to be familiar with. If you're not familiar with those, you can look them up, or later on in this class, once we've covered a couple of exams, I think we might start covering some material. And once we get to that point, I think we will be able to cover the divisibility tests. But yeah, that's what we see here. Another thing about this is, for the way that the test works for 9, something that's a little bit interesting is it turns out any multiple of 9 added on to another multiple of 9 is always a multiple of 9. So what that means is, instead of saying, oh, I need to add together all the numbers to reach a multiple of 9, instead what I can say is I can remove multiples of 9 as I see them. So for example, 1 plus 8 is a multiple of 9. So that means that 2 plus u must also be a multiple of 9. In this case, the question is being pretty simple anyways, but had there been more digits, this would be a more important question to do. Like, this would be, more important of a property to take advantage of. All right, any questions here? Once again, another pre-algebra method. All right, problem number 8. Stella, this one's yours.
Mr. Garcia asked the members of his health class how many days last week they exercised for at least 30 minutes. The results are summarized in the following bar graph, where the heights of the bars represent the number of students. What was the mean number of days of exercise last week, rounded to the nearest hundredth, reported by the students in Mr. Garcia's class?
Any ideas on what we need to do here? Stella?
I would just add up the total number of days of exercise and then divide it by the number of students.
Okay, so that's the definition of mean, right? So the mean is, so can you give me what that definition is actually? So mean is the same thing as average, which is the same thing as?
The sum of all the values divided by the number of the values.
Yeah, sum of all values divided by number of values, right? So in other words, right, the sum of each student, the number of days that they exercised, right? The sum of each individual student divided by the number of students that you have in this case, right? So first off, how many students do we have in this question? Stella, how many students do we have?
25.
So that's going to be 1, 3, 2, 6, 8, 3, and 2, right? So adding all those up, making things a little bit nicer. This is 2, this is 10, this is 10 here. That's 5. Yep, 25 is our answer. So it's equal to something over 25. Okay. What about the sum of the values? How do we do that? Do we just have to do 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus... Do we have to add up 25 different numbers?
You could, for each bar, you could multiply the number of days of exercise multiplied by the number of students.
Yeah, you could. Instead of doing 2 plus 2 plus 2, right, you could recognize, hey, this is the same thing as 3 times 2. Instead of doing, any of that, right, for especially once you get to 4 or 5, right, things get a little bit more difficult, right? So you can just do 1 plus, 3 times 2 is 6 plus 24 plus 40 plus 18 plus 14, right? That's a lot, it's still a lot to do, but it's a lot nicer than having to do, it's a lot nicer than having to do all those 25 different numbers added together, right? Okay, so what is this equal to here?
I got 109.
109 is correct. So you're looking at 109 over 25. So our correct answer here should be?
I haven't solved it yet.
So we can actually see pretty quickly what our answer should be, right? 5.0 means that our numerator divided by denominator needs to be 5. That's going to be 125 over 5, right? So that's too big. 3s means that we're lower than 100 over 25. So that means that anything in the 3s is too small. 4.5 means that we'd actually have to have exactly, 4 times plus another half. That's 112.5. So D is also wrong. So our answer here has to be C. Does that make sense?
Yeah.
Yeah, so here you could kind of get an idea of that, right? But if you go ahead and directly divide 109 divided by 25, you should find that this is equal to 109 over 25. You'll find that that's equal to 4 points. If you actually go ahead and do it, so 0.375. Okay, I'm done. I know 4.5 is wrong. I'm done. It's 4.36. And that's another way that you can do this question. Well, that's another way that you can, do that division last part. But that's what we see here. 4.36 is our answer. Any questions here?
How did you get the 25?
We just counted out the total number of students. We added up all the students in each number of days, and we got that 25.
Okay.
Any other questions here? If not, then I think we have enough time to do one last question. Oh, this is the pre-algebra book, chapter 13. It's a statistics question, and that's what that chapter covers. All right, one last problem. Problem number 9. Okay, let's see. Any volunteers for problem number 9? Going once, going twice. Okay, Matthew, how about you do this one as well?
Jenica is tiling the floor of her 12-foot by 16-foot living room. She plans to place 1 foot by 1 foot square tiles to form a border along the edges of the room and to fill the rest of the floor with 2 foot by 2 foot square tiles. How many tiles will she use?
Okay, any thoughts?
So that means that all the tiles that are touching the border are 1 foot by 1 foot tiles.
Right, so how many tiles are there going to be here that are 1 foot by 1 foot? How many tiles are there on the outer edge?
52.
And how did you get that number?
So first, what I did, I added, since there's 1 tile for each foot, so I would add 12 plus 12 for the 2 sides.
All right,
to
so
get-
12 here, 12 here, right?
Yeah, so that would give you 24.
Right.
But then since they've since all the corners are already counted, you would subtract 2 from both sides, the remaining sides, which would give you 14 and 14, which
Right.
you would add to get 52.
Right, so you have 12 plus 12 plus 14 plus 14. I agree. Okay, and what about the area in the middle then? How many 2 by 2s would fit here?
So so first I think we should figure out the border of the remaining space.
So what is the border?
It's 10 by 14.
10 feet here, 14 feet here, right? You picked off 2 feet here, 1 foot on either end, 1 foot on either end. I agree. So the total area remaining is 140, right? Or 14 times 10.
Yeah.
Okay, what now?
I think it might be better to divide the dimensions in half to make it easier so we can imagine it as 1 foot tiles.
Okay, so you're saying instead of thinking of it as 10 foot by 14 foot, think of it as 7 by 5s, right?
Yeah.
In other words, 7 of the 2 by 2s can fit down this way, and then 5 of them can fit down this way, right?
Yeah.
So how many total tiles is that going to be?
35.
So 35 tiles here. So how many total tiles together?
87.
And that's it. B is our answer. So the hard part about this is understanding that when I'm counting how many 1 by 1 tiles, it's not 12 plus 12 plus 16 plus 16. And the reason why is the corner has already been placed. So I only need another 14 in the middle. That's the big idea here. And then remembering that after I've taken care of that, the remaining portion is just 10 by 14, right? Because I've already taken care of the outer edges. So those two are the important details here. So 87 is the correct answer here. And next time around, we're going to continue on from problem number 10. So I'm going to, that's going to be about it here for this week. Homework is going to be to take a look at those problems, starting from problem number 10 all the way up to problem around 20 or so. We're going to get through as many as we can, but with that, if you guys have any questions, feel free to stick around. Otherwise, that's going to be it here for today, and I'll see you all next week.
How did you get the 14 from the 16?
Remember, we put one tile on the left, one tile on the right. So those 2 feet were already taken up. So so all that was left was 14 feet.
Okay.
Yeah.
Thank you.
Sure.
Bye.
See ya.